Morning, peeps. How are we? Lies, right? Today, it's about lies and how lies can affect people's realities. Because if somebody tells you a lie and you live your life by that lie, you're living a certain reality, aren't you? Now, so many people are in so many positions where they don't think they need to be questioned, but they do, especially when you find out some of these lies. Now, there's no way of doing this in a 5 minute. So we're going to go straight to black holes, right? Now, for me, every time I've witnessed a solar eclipse, you have the sun at the back, the moon smack bang in front of it, and you're in the sweet spot shadow. Now, my common sense, logic, rational thought process, everything. The sun's light is absolute. There is no other explanation for a solar eclipse and the way it plays out, okay? Knowing that, all of these studies and everything that has ever been done is unfortunately using a speed of light that travels at 299,792 kilometers per second, or 299,792,458 meters per second. So, for me, anything that has a speed of light in an equation with 299,792 in it is wrong. It just is, unless somebody tells me a proper, logical, I am not an idiot explanation for why the sun is directly behind the moon during a solar eclipse. Anything, all these books, hey, listen, it's one or the other. The two cannot coexist. A solar eclipse cannot coexist in a universe that has stars that are radiating their light at 299,792 kilometers per second. It just does not work, does it? So, what did I do? 1961, encyclopedia time. Black hole, blah, 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 BL, not even a scratch in daddy's pants. 1961, 1966, no black hole, nothing, just nothing. So I carried on, boom, 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 and the very, very, very first mention that a black hole is even a thing was in my 1971, I do believe. I've got all these books here, right? I've got so many that I've actually got my knickers in a twist. Now, it's the 1974. All right, now this is what it says for black hole. When stars several times bigger than the sun reach the end of their lives, they flare up in a violent explosion called a supernova. The outer regions of the star are thrown off in a supernova, but a core of densely packed material remains. This may form a pulsar. However, if there is enough material, a possible black hole. Now this was 1974. Now, I went into the 1975, and I'm talking the big 1975, right? This. I mean, come on, all right? So what we have, I look for black hole, and look at this. Massive write up, right? 1975. I mean, hang on. It goes, all right. Black holes of Calcutta. All right. So we've got all of this now, right? This is 1975. Remember the astronomy book where it said it's 1975 and they still haven't discovered one. Yada yada. So it's just like one of the Einstein. Well, no, it's not. It goes back to the 1700s. the first person, somebody, you know how it is, the little push, like the Roma, the little push for some kind of a light delay. Well, somebody before Einstein had highly recommended it, apparently. Right, black hole in space, postulated object whose mass is so intensely concentrated that normal properties of space in its vicinity are altered drastically, and even light cannot escape the gravitational attraction within a certain distance from the center. No black hole has been certainly identified, and the best way of trying to identify one is still uncertain. This is the 1975, so they're all agreeing, right? So we'll skip a couple of the 1970 jobbers, and we're going to jump into 1984, which is one of the later ones that I have. So here we go, 1984, black hole. We just have that, okay? And then it goes on to that black hole of Calcutta, which was an incident that took place in, anyway, sorry if things didn't turn out well on that one. Black hole is an invisible object that astronomers believe exists in space. It has such a strong gravitational force that nothing, not even light, can escape from it. Some astronomers think a black hole may form when a large star collapses inward from its own weight. The star is compressed as it collapses, and its density increases greatly. The extreme density of the collapsed star causes its surface gravitational force to increase tremendously. This force becomes so great that a star's light cannot escape, and the star becomes invisible. Astronomers visualize such a collapsed star as a hole in space. The hole may attract and retain nearby orbiting objects, including comets and planets. When a star becomes a black hole, its size decreases greatly. The sun, which is a star, has a diameter of about 1,308 kilometers. To become a black hole, the sun would have to be compressed to a diameter of less than 4 miles. Well, I think we can all agree that we cannot compress our sun down to a diameter of 4 miles or 6 kilometers. Can we? I mean, who's going to compress even planet Earth with a diameter of 12,742 kilometers down to the same as the star would need to go down to 4 kilometers? How do you compress a planet like this with a diameter of 12,742 kilometers down to a diameter of 3 or 4 kilometers or 5? What are we talking here? Gravitation. Listen, during an eclipse, right, this thing goes on. Where are we? When it started out, astronomers have been unable to prove the existence of black holes because the holes are invisible. These scientists have tried to locate black holes by observing the effect of their gravitational pull on other objects. During the early 1970s, some astronomers discovered a star that orbited what seemed to be an invisible object in the constellation Cygnus. They believe this object was a black hole. Some astronomers think black holes make up as much as a third of the material in the Earth's galaxy, the Milky Way. Now that is all. 1984. No mention of a black hole. But the funny thing is, in all of the encyclopedias, like my 1970s, 1980s, right? What we have is an invisible object that astronomers believe exists in space. It has such a strong gravity. It's the same explanation. Now this is 1979. The 1984, you just heard. So, according to everything that I've seen, the very, very, very first time that there was actual evidence for a black hole was LIGO with gravitational waves. Now, the gravitational waves travel at the same speed as the speed of light, 299,792 kilometers per second. Now, listen, it's one or the other, isn't it? This These gravitational waves right here, I'm using logic and common sense, right? Perfectly logical, what I'm saying. These gravitational waves cannot coexist in the same universe as a planet that observes a solar eclipse with its star and its moon getting in front of the star and radiating absolute light, because it is absolute light. It does not matter what anybody says. There is as much sign during a solar eclipse that we're trickle feeding the speed of light as there is evidence of dragons on this planet. I mean the flying ones that spit fire. There is zero evidence. Now, I could grab that, go out and aim it towards the sun and say 8 minutes and 20 seconds. But I think most of you know by now. Let's do it anyway. This is the lies that have been told. How on earth can anyone think that that takes, I struggle with the words now. 8 minutes and 20 seconds for photons. Probably some dark photons come down now, don't they? They probably head into the darker corners and keep it all shaded for us so that our drinks don't get too hot. Now, if you look online and you start Googling black holes, when were they discovered, there are a few irregularities, right, with dates and stuff. Because you don't have the books, you're at the mercy of what they tell you, aren't you? So here, I've been looking, going back and forth. Now listen to this. Don't forget, this is the first time that they reckon that they have evidence. The gravitational waves that were traveling at the speed of light. So that would mean 299792, that bang, they've detected them at a certain, I don't know how many, if it's billions or trillions of years after the event, right? Because these gravitational waves are not going to go on forever and ever. Because they're finite, that means that when they were passing LIGO, they had to pass at a specific time, because it took X amount of years for this pack of gravitational waves to travel. After this packet, there can't be anything here. There simply can't be anything here, right? It's one moment in time. It's finite light. You cannot see, you would not know the sun had gone out for 8 minutes and 20 seconds after the event. This means it travels, light travels in a bunch, a packet, right? Which is what they say. So, two black holes collide, whatever, bang, right? Create gravitational waves. Those waves then leave the event, but it's a moment in time. There's not going to be a record of it behind it, because it happened, some waves came out. After the waves, it goes quiet. The event happened, these waves are now continuing towards Earth, right? They just so happened to detect these waves as just, I think it was like 10 or 15 minutes after they switched. I mean, the story of how it happened is as unbelievable as light traveling at 299,792 kilometers per second. I'm very serious about this. All somebody needs to do is come up with a logical explanation, one that ties in with common sense. Don't give me this science doesn't care about your common sense. I care about my common sense, right? An explanation that will show logic behind what we see during a solar eclipse. It's that simple. Nobody's going to tell me that it takes any amount of time for anything to get to us from the sun, because I can see a solar eclipse. I'm not stupid. It doesn't matter. I don't care how many books say that the sun isn't behind the moon during a solar eclipse. It clearly is. I'm not an idiot, right? So all of this stuff is a lie. How can you say that? Well, oh, solar eclipse. Come up with a perfectly logical solution for when the moon comes across, gets to the sun, slowly darkens it until we're all in the dark and we can see the corona in real time, ladies and gentlemen, and then the moon carries on and it gets brighter again. How does that happen so precise at the very same time as it seems to be happening? Like I said, I'm not an idiot. So these gravitational waves travel, I'm not even going to bother to see how long ago this thing happened. So they get these waves, and they go, oh, look, we just turned it on. You're not going to believe this. Fucking black hole waves, isn't it? First of all, these waves that came, how did they work out that they were from a black hole? Because of Einstein's stuff earlier, a certain signature, if you will. Okay. How did they know how far away they came from? It's just a moment in time. Hey, look, we've got some waves here. Something's blip, 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 blip. And then, okay. So what do they do now? What is it? The new Microsoft program that you click the disk in and it works out exactly how many millions or billions of light years away the wave that has just passed the equipment was. No. The likelihood is it's just lies. How do we know? The solar eclipse will cancel all of this out. It's so obvious that this stuff is a tweak on people's realities. I'm being deadly serious. The lies that people tell, they don't give a toss about the results of the lies or how people are living their lives. They just lie. Why wouldn't you? When was the last time anybody actually, right, show me? You don't. You just accept everything. It's been going on for decades, centuries probably. Now listen, this is about black holes. 50 facts or something. It goes on for 50 minutes. If you don't listen to these things, if you don't look at the small print, if you just accept everything at face value, look where we are. That book is obviously in front of the remote sensor, or this thing broke the other night when I dropped it. No, it can't, because I used it earlier.
You find yourself tumbling through space. Moments before, you were just on a routine spacewalk, examining some minor cosmetic damage on your ship, when suddenly you started feeling strange. You felt a lurching in your stomach as your body started accelerating.
10 years.
Now you find yourself hurtling helplessly through deep space in the direction of the universe's most powerful, most mysterious killer, a black hole. You need to understand black holes, and fast. Here are 50 insane facts that may help.
Facts.
Fact 1. A black hole is a point in space that has such a strong gravitational pull that nothing can escape it, not even light.
Now, when they say light, I presume they're talking about light that travels at 299,792 kilometers per second. Obviously. But if that's the case, it can't be the same light that's radiating from the sun, because when the moon gets in front of it, it's clearly, there is no doubt whatsoever, no explanation, no fantasy land that could convince me that it's not absolute. How? See, this is how it works. I believe what I see with my own two eyes. Therefore, the rest of all of this must be a lie. Just one explanation, please, of how the moon, when it moves in front of the sun, why does everything seem to be happening in that moment? I tell you why, because the sun's light is absolute.
Our sense of sight relies heavily on either seeing the light emitted or reflected from the surface of objects. A black hole doesn't let that happen. Fact 2. The border at which light can no longer escape is...
Our eyesight, it relies on the light that bounces off of the surface of things. Now, that is something that happens because the light from the sun is finite. They're telling you that you need to wait 8 minutes and 20 seconds for those photon thingamajigs. Arrive, hit the grass, bang, dong, green. No. When you look at something outside of your head, like I'm looking at the grass behind you now, it's green. I don't need to wait for the photons to come and tell me in my brain. My eyesight sees that where it is. It's green. If the sun went out right now, that grass remains green, but in the dark, so I can't see it. It's this again. It is a fact because when you observe a solar eclipse, the sun's light is absolute. There is no Mickey Mouse delay.
known as the event horizon. Since light is the fastest thing in the universe, and it has the best chance of getting away, it's safe to say that anything else passing the event horizon will also end up tumbling in. Fact 3. Right now, you're hurtling toward the event horizon, going fast.
Oh no, no, oh, it's an ad.
Steakhouse
Look,
crackers are packed with tasty
all of
dates
this
and apricots that make cutters
is
great.
with finite light.
Recycle.
Your whole reality.
Faster and faster. What'll happen if you go past it? Well, the process called spaghettification. And yes, that is its real name. Going feet first, the gravitational force affecting your feet will be stronger than it is at your head, meaning your toes will be stretched away from the rest of your body. At the same time, they'll be compressed together, forced into a tinier and tinier space, meaning that you'll be strung and stretched into a piece of human spaghetti for the black hole to slurp up. Delicious. Fact 4. If you look down, all you'll see is blackness as no light is rising up toward you from the black hole. But if you manage to crane your head just enough to look behind you on your way in, you'll be able to see where you have come from. That's because the light behind you is traveling in the same direction you are and at a greater speed, so the photons will still hit your eyes. Fact 5. Soon you...
Now, photons are things like we have photons traveling from the sun in invisible massless packets of invisible massless photons, and apparently dark photons are somewhere in that bag. But these photons are traveling at 299,792 kilometers per second. But how is that possible if during a solar eclipse, right, you think I might be repeating this a little bit too much, but I do not think people realize how easy this BS is to work out. Yes, but all of the teachings and the... Look, if one of you guys were taught this and became a professor, you would pass the lie on because you believe it all. You've never had a reason to question it. But if a solar eclipse is not reason enough to question what they're telling you, then what is? You don't think that you on your own can work out that the light radiating from that sun is absolute. You're witnessing, observing a solar eclipse. You're telling me that you have not got enough trust in your own judgment to look at that eclipse happening and say, that's got to be absolute light. There's no other way that's going to work. And you believe all of these lies rather than what is happening right in front of your very own eyes. This is the dilemma, ladies and gentlemen. It's you're just not trusting your own judgment for some reason. Because trusting your own judgment, all of these complications and these black holes, everything, I tell you what, they do not exist. They cannot exist in a universe where when there is a planet going through a solar eclipse and its moon is being blocked, or its star, the light from its star is being blocked by its moon. it cannot coexist with a speed of light. Oh, cheers, mate. Thank you. It's one or the other. So nobody's going to be able to talk me into photons taking 8 minutes and look.
You'll pass the photon sphere, and things will start to look weird. Your window of the universe curves up and away from you, steadily shrinking smaller and smaller, giving you one last glimpse of your crewmates waving at you from the escaping ship. Fact 6. But the fate actually depends on the kind of black hole you're in. The spaghettification happens if you're falling into a stellar black hole. A supermassive black hole will be much stronger, but will treat you slightly better. That's because the stretching tidal force is less there. But bad luck, you're still not making it out. Or could you? To understand your chances at escape, you'll need to understand first black holes in a bit more detail. Fact 7. Since they're black, and space is also black, it took scientists a long time to realize they were even there. As far back as 1780.
Those scientists that keep saying black holes black, space is black, they're lying. Do you know how we know this? Because when you observe a solar eclipse.
Before, an astronomer by the name of John Mitchell theorized that such a thing could exist. He called them dark stars and thought that they were
1784.
normal functioning suns like our own. His theory was that they were so big and heavy, 500 times the diameter of our sun, that the light particles would fly away out of them, gradually slow down, and be pulled straight back in by the
1784, 100 years before electricity. This guy, he's just laid the groundwork, foundations down. Can't find him in any encyclopedia's mind.
force of gravity. Of course, his theory doesn't really hold water today, as we know that the speed of light is
Can't live without Netflix? Join the
See?
HBO Netflix electricity plan. Netflix included
Now-
for the life of your plan.
That's not the speed of light that I'm living my life by, because when I see my moon plonk itself in front of the sun, it's happening in real time, there's no delay. I'd be an idiot to think there is a delay there, wouldn't I?
constant. You can't simply slow it down. And that light isn't a particle, or is it? More on that later. For
My son
now,
just bought me
let's
breakfast.
focus on the black holes themselves. Fact 8. Where do black holes come from? Well, let's start with a cloud of dust and gas, or a nebula. Loose matter floats around in space. Each particle has a tiny gravitational pull, and so they eventually start clumping together. The more it all clumps together, the more mass it has. The more mass it has, the stronger its gravitational pull, meaning more dust and gas. In the middle of things, the particles start colliding more and more. Each collision produces some heat. Keep this going long enough, and soon you're cooking with a main sequence star. The outward pressure of the nuclear fusion reactions in the middle balances out the gravitational forces pulling everything toward its core. And so this star is happy and healthy for billions of years. Our own sun is in the middle of this era, but all good things eventually come to an end. If the star is big enough, then eventually it'll no longer have enough energy to balance out the forces of its own gravity. It'll have one last giant explosion called a supernova, and leave behind an incredibly dense core that collapsed.
And when that supernova happens, the light obviously travels at 299,792 kilometers per second. But obviously not in this universe, it wouldn't. Not in my one, where I can clearly see the sun, the moon directly in front of it, blocking it out in real time, there's no doubt. So this must be some alternate Mickey Mouse universe somewhere.
Is in on itself and forms a black hole. Fact 9. The core crushes itself smaller and smaller and smaller infinitely. The point of a black hole is infinitely dense and infinitely small. The core that was once as heavy as 10 of our suns crushes itself to be smaller than an atom, smaller than a nucleus, smaller than a proton, smaller than a quark, all the way down to a Planck length. But at that point, the universe hits its size limit. Quantum physics and our models of reality simply cannot compute anything beyond that point, as the wheels all...
I'm thinking that the reality thing, right? We left reality long before we got to this spot here.
fall off the carriage. We can't even know what happens with any certainty beyond that small of a point. since the concept of happens no longer even applies. Fact 10. If you want to understand just how small the Planck length really is, take a picture of a speck of dust by your window. Compare that speck of dust to the size of the Earth. It's tiny, but on a log scale, that speck of dust is the halfway point between the mass of the Earth and the mass of an atom. Fact 11. But the size of an atom is 100,000 times bigger than its nucleus. So if the atom was the size of the biggest NFL stadium in the US, the nucleus would be a marble in the middle of the field. So that's almost the size of a Planck length, right? Fact 12.
Now listen here, folks. You take a picture of a piece of dust. So let's just say that, let's just say, like, there's a little piece of chalk dust on there. You take a picture of it and you blow it up. You zoom in and you increase it until it's the size of planet Earth. Let's just make sure we've got this right. This is about looking at what they are saying, okay?
Of a speck of dust by your window. Of happens no longer even applies. Fact 10. If you want to understand just how small the Planck length really is,
Dust.
take a picture of a speck of dust by your window. Compare that speck of dust to the size of the Earth. It's tiny, but on a log scale, that speck of dust is the halfway point between the mass of the Earth and the mass of an atom. Fact 11. But the...
Can you see what we're talking here? So you need to blow that dust, that speck of dust up to the size of Earth, right? And that speck of dust is now the halfway point. Sure.
Lies. Fact 10. If you want to understand just how small the Planck length really is, take a picture of a speck of dust by your window. Compare that speck of dust to the size of the Earth. It's tiny, but on a log scale, that speck of dust is the halfway point between the mass of the Earth and the mass of an atom. Fact 11.
Right. So you have got planet Earth, 12,742 kilometers in diameter. You then have dust, a little speck of dust, right? And here's Earth, here's a tiny speck of dust. This speck of dust is the halfway point on the way down to the size of an atom. That's small, right? From planet Earth all the way down to a speck of dust, right? And the speck of dust is the halfway point, size-wise. I mean, we are talking what? It's where the quantum world begins, isn't it?
11. But the size of an atom is 100,000 times bigger than its nucleus. So if the atom was the size of the biggest NFL stadium in the US, the nucleus would be a marble in the middle of the field. So that's almost the size of a Planck length, right? Fact 12. Nope. You need to go a quadrillion times smaller than that, and then do the football stadium and marble trick again. If the whole Earth was the size of an atom, a Planck length would be smaller than a proton in the core of the Earth. Fact 13. So,
I'm calling bullshit when you listen to this, right?
what's at the other end of the scale? If the singularity at the core of a black hole is compacting it down to be the smallest thing, what's the biggest thing? You guessed it, black holes. Fact 14. Black holes are measured in solar masses. In other words, that's the mass of our very own sun. This mass is 2 times 10 to the 30th kilograms. That's 2 with 30 zeros after it, or 2 nonillion kilograms. Fact 15. A black hole the size of Japan would weigh about 140 solar masses. That's 140 of our suns squashed to 0.001% of their usual size. Fact 16. We have a gap in our black hole size comparison chart. A big gap. Scientists have observed plenty of black holes around this size range in up to about 150 solar masses. The next ones up in size are millions of solar masses. Why aren't there any in between these two? Find out and you could win a Nobel Prize. Fact 17. What's worse than one black hole? 2.
You mean like the Nobel Prize that those three, at one stage, the most intelligent minds on this planet. They worked out, they proved, they discovered that the local universe isn't real. Is that the kind of Nobel Prize one can win if one guesses about the gap in between the largest of the black holes and the smallest? See, the black holes cannot coexist in a universe where solar eclipses play out like the ones that we see. It's really very, very simple. So this is obviously fantasy land.
Since they are so
It
massive,
is.
they tend to attract other equally massive bodies toward themselves, including other black holes. That's right, black holes can join together to be even bigger and badder. Fact 18. When two black holes join together, they release the most energy of any known phenomenon in the universe besides...
That's all the balloons we had.
It's really negative, isn't it? Black hole, black this, black there. It's just really, 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 it's like way back in the subconscious, isn't it? This constant, yeah, I do believe so. But this
Well, your
black holes are
pipeline's maybe up in
bullshit
the air, but at least
because
your insurance is sorted.
It's good you went by.
you need light to be travelling at a rate of 299,792 kilometers per second for
It's the Big
all
Bang.
of this to
Two
be
massive bodies weighing the
feasible.
equivalent of a couple of million stars each,
Eclipse.
swirling around and around, getting closer and closer to each other, and sending incredibly powerful gravitational waves rippling through space in their wake. Fact 19. We all know that black holes can crush you, but do you think you could ever have a crush on a black hole? The iconic meme character Black Hole Chan is based on the personification of a black hole in the form of an anime girl, because certain parts of the internet are just like that. Specifically, she's based on the black hole in the center of Messier 87 galaxy, which became a generally huge meme in 2019 when a photo of it was successfully captured by NASA's Event Horizon telescope and released to
Ah, why would? Ah,
the public. Fact 20. Black holes have a bit of a bad rep for sucking in stars and galaxies, but did you know that they can have an equally important role in creating them? According to a 2018 study, fragments loosed from black holes can sometimes create entirely new stars, and supermassive black holes sometimes play a part in determining how many stars a new galaxy has by influencing the process of star formation. According to the study, the smaller the black hole in the center of a galaxy, the sooner the process of star formation turns off, leading to smaller galaxies in turn.
now we're talking about the formation of stars. Don't these things take quite a long time? How do they know all of it? Look, it's just a load of horseradish. Honestly, it is just a load of garbage.
Fact 21. Sagittarius A is the black hole at the center of our galaxy. The Milky Way is much, much smaller than that in comparison. Its radius is only 17 times our sun. It's tiny, and so our galaxy is fairly stable. Fact 22. So, what's the biggest black hole ever? Well, the biggest we've found so far is Phoenix A. You can find it at the center of the Phoenix cluster, and don't worry, it's about 5.8 billion light years away, so you won't
5.8 billion light years away. But a light year means that light is traveling at 299,792 kilometers per second. Now, that is not happening during a solar eclipse. I have to repeat this so that it's quite clear what I'm saying, right? This is very, I have to say it, black and white, right? Poles apart here. What's happening here is, on this planet, in this universe, when there's a solar eclipse, the moon, you'll see the moon in the sky, right? And as we spin on our axis, it slowly appears to cover the sun up. As soon as it starts to cover that sun up, the light drops ever so slightly. Now, as it plays out and it ends up as a poof, total solar eclipse, it's all happened in real time. We've seen the light disappear at the same time, and we've seen the sun get covered up at the same time as all this is happening. And you are in the shadow if you're in the sweet spot. Now, how on earth does all of that happen if the light traveling from the sun is traveling at 299? It can't happen. Only happens with absolute light. Whether you want to believe me or not is kind of irrelevant. The more important thing is about believing what your own eyes are telling you, because they're telling you that that is not happening. When it's happening, it's not happening, isn't it? So for me, I mean, it's easy. That's why a lot of these things defies common sense. Yeah, but common sense, well, common sense. You have a moon and a sun and a star. Don't talk to me about common sense if you can't work that one out. Please, don't talk to me about
Won't be falling into it anytime soon. Fact 23. The previous record holder, TON 618, was pretty terrifying already, but Phoenix A is 1.5 times bigger than even that. Fact 24. The numbers get even more ridiculous. It weighs the same as 100 billion suns. Fact 25. You could fit the entire solar.
We get that flavour is your love language. Flavour needs to be real tasty, real fast.
Under siege.
And flavour beats fussy every time. Campbell's.
Under siege.
We get
Liars. Liars altering people's realities, wanting you to live their reality, where they've moulded bits and pieces for you.
Solar system into its diameter 50 times over. Fact 26. A photon of light that falls inside its event horizon would take well over a week to reach the singularity at its center. Fact 27.
Now, a photon that will take how long? But that's because that photon exists and it's traveling at 200. But when you look at a solar eclipse, see, this is exactly how it works. Every time I hear something, I go, hang on a minute, how come when I see a solar eclipse, that must be a lie? Or I'm just a idiot and I can't work out the photon thing from what's happening. I must be missing something.
Scientists have had to come up with a new category for black holes to accommodate such gargantuan celestial bodies, ultra-massive black holes. Fact 28. But now Phoenix A has pushed for an even bigger category, stupendously large black holes, or slabs. Who says physics can't be
You
fun?
know what? I've had enough. I've had enough. We could go on and listen to that garbage. Now the whole of we are talking black alpha waves heal the whole body and spirit. 15 cent facts, that's what we just watched. Black holes explained from birth to death. Black holes 101, National Geographic. Brian Cox on how black holes could unlock the mysteries probably of the universe. The weird physics surrounding black holes that will make you whatever. Black holes, everything you should know. A quantum space, Why black hole environments are a lot more complicated. The largest black hole in the universe, size comparison. Biggest black hole ever discovered, tons, 618 that is. Why time stops in a black hole? We finally know! Alternate dimensions inside black holes. 14 minutes of it. Oh, it's Neil. You're getting sucked into a black hole. The other side of a black hole. Black hole's evil twin. Gravistars explained. Why time and space swap in a black hole? What is inside a black hole? Why black holes break the universe? Is our universe inside a supermassive black hole? What if I threw you into a black hole? The most astonishing theory of black holes ever proposed. Supermassive black holes, how the universe works. Live, now. Scientists have opened the portal to, No. Just advanced, JWST, Advanced Deep Survey, suggests our universe. Time is relative, Neil. No. Biggest black holes. Did the future already happen? The paradox of time. Black hole versus neutron star. Who wins? Before Big Bang. Who created nothing? Our universe formed from. Scientists find what's inside a black hole. Einstein's special relativity theory does time really slow probably down when black holes collide. The universe as you know it does not exist. Let me explain. Time does not exist. Let me explain with a graph. The most dangerous star in our galaxy could explode any moment, I guess that last word is. Wormholes explain breaking space-time. How we know that Einstein's general relativity can't be quite right. Time lapse of the future, a journey to the end of time. The universe is not real. How physicists prove the universe isn't logically. Sleeping Beauty paradox, the most controversial problem in philosophy. We travelled back in time. Now physicists are angry. Time dilation, Einstein's theory of relativity explained. What happens if you destroy a black hole? Einstein and the theory of relativity. 600,000 sun black holes found next door without light. Brian Cox, incomprehensible scales that. How did everything start from nothing? Exploring the mystery of black hole. How big is incompleteness? Energy is not conserved. The last thing to ever happen in the universe. James Webb Space Telescope finally sees what's inside a black hole. It's time to travel. Is time travel possible in our universe? How one line in the oldest math text hinted at hidden. The black hole could be bigger than the universe. James Webb Telescope finally sees what's inside a black hole. Black holes, everything you should know. A quantum space bullshit story. What is inside a black hole? Falling into a black hole. The largest black hole. Ha ha ha. Black hole. Planet humans. Baby black hole's friend. How tiny can a black hole be? Turning into a black hole. Planet humans. Brian Cox explains. Monster Black Hole, full documentary. You're getting sucked into a black hole. The most. Just me clicking. Click. Ladies and gentlemen, you are being hustled, and your actual reality is being created for you, and all you need to do to work this out is observe a solar eclipse and tell yourself that the sun is not directly behind the moon as it's taking place. Stop being silly. Later, peeps.